Hello, everyone. Today I'm going to be discussing the bridge pattern. This is a structural design pattern, and my name is Sonia Potu. Let's get started. Great. So, what is the intent of the bridge pattern? So, the bridge pattern basically decoupled abstraction from the implementation to allow independent development. It promotes flexibility and code maintainability. Those are a lot of words. So, what it does is it separates the what from the how, and it separates the high-level functionality from the details of how it's implemented. And this makes it easier to change or update either part without affecting the other. So it solves the problem of having too many classes when we need different combination of features. And it also allows us to connect parts together at runtime, making the system more flexible and easier to maintain. So when should we use the bridge pattern? So we use the bridge pattern when we need to separate abstraction from implementation. So keeping the high level logic separate from its details. When we're expecting changes in both. So when we're expecting changes both in the abstraction and its implementation. When there's too many combinations, subclasses results in too many combination of the classes. And then when we want to avoid changing code that already works. Okay. So the bridge pattern consists of four main components. So we have the abstraction class. So the abstraction class defines the high-level interface. It contains a reference to the implementer and delegates the work to it. This is where the core functionality is defined, but it is abstracted from the specific implementation details. The refined abstraction extends the abstraction class and provides additional functionality or specific behavior. And it can add extra operations or modify the existing ones, but still delegates the core tasks the implementer, sorry. The implementer class defines the interface for the implementation, and it provides the low-level functionality that the abstraction class depends on. And the implementer class doesn't know about the high-level abstraction. It just focuses on providing the necessary functionality. Okay. And the concrete implementer class is a specific implementation of the implementer interface. It provides the actual behavior for the functionality that was defined in the implementer. This is the class that gets used by the abstraction to perform its tasks. So by using this structure, we can change the implementation without affecting the abstraction, and we can add new abstractions without changing the existing implementation code. Okay. So for my use of the bridge pattern, I decided to make a payment processing system. Right. So in our payment processing system, we can apply the bridge pattern to create a flexible, decoupled structure for our payment methods and payment gateways. So first we have the implementer, so the bridge. Or the bridge. The implementer defines the interface for the payment gateways. It ensures that any class that inherits from the payment gateway interface must implement key methods like process payment and process refund. And this structure allows us easily to add new gateways in the future while keeping them consistent. Right, and the concrete implementers. So this is the specific payment gateways, and these classes provide actual implementations of the payment gateways interface. Each specific gateway, such as PayPal, Stripe, credit card, has its own processing payments and refunds. By using different concrete implementers, we can support various payment systems without changing the abstraction or payment methods. Okay, so abstraction. So abstraction defines the interface for the different payment methods. It acts as a bridge between the payment methods like credit card, bank transfer, PayPal, and the actual payment gateway. So the gateway attributes determine which payment gateways to use for the processing transactions. The pay and refund methods are abstract and must be implemented by their subclasses. Okay. Right, and then refined abstraction. So these specific payment methods, and these classes represent specific payment methods such as the credit card payment, PayPal payment, and they extend the payment method class and then implement the pay and refund methods. So each payment method delegates the actual processing to the selected payment gateway, so we can easily switch gateways based on the method chosen by the user. Okay. And then here are some other classes just for the user interface and to be able to create payment methods and view history and view the available gateways. So the payment processor class manages all the available payment gateways, creates payment methods and tracks transaction history, and it lets users um, select payments. Users select payment methods, process payments, and issue refunds. Um, Also, the processor payments class allows us to retrieve the payment method and record the transaction history. And then we have process refund, which processes a refund and records the transaction history. And then we also have the data display transaction. This displays all the process payments and refunds and the interactive menu. Gives us a menu for us to interact with and be able to use all of these options here. So with this bridge pattern structure, we could easily add new payment gateways or payment methods without needing to change the core logic of our system. So this allows for scalability, flexibility, and easy maintenance of the payment processing architecture. And here is the UML diagram for this, and as I explained, for each class. Okay, so now let's discuss the consequences of using the bridge pattern in our design. So like any design pattern, it comes with pros and cons. So it separates abstraction and implementation for flexibility. So um, the bridge pattern separates the abstraction from its implementation, giving us the ability to vary and extend both independently. So this makes it easier to swap up the different implementations or add new ones without disturbing the abstraction. And by decoupling the abstraction and implementation, we can extend the code more easily. So for example, we can add a new payment method or a new gateway, and this can be done independently without affecting other parts of the system, making the code more maintainable in the long term. Also, it reduces complexity. So the bridge pattern reduces the need for the complex inheritance hierarchy. So instead of creating multiple subclasses to handle different combination of abstractions and implementations, the pattern allows us to keep it simple and manageable, which reduces the overall complexity. So the cons is on the downside is that it can increase the number of classes in the system. So while the pattern decouples components, it does introduce more layers of abstraction, which might feel like an overhead in your system. And adds indirection, making code harder to follow. So another potential drawback is the added indirection can make the code a little bit more difficult to follow since the logic is split across multiple classes and interfaces. So developers might need to trace through several layers to understand how the system used. And then when to use. So the bridge pattern is ideal when abstraction and implementation need to vary independently. So if you have a system where you anticipate frequent changes, either the abstraction, like different payment methods, or implementation, like different payment gateways, this payment helps manage those changes without creating a tangled web of classes. Okay, so overall, the bridge pattern introduces some extra complexity, its benefits in terms of flexibility and maintainability, and make it a powerful choice when you need to decouple abstractions from implementations. And some specific real-world applications are UI frameworks. So this separates platform-specific UI and logic, payment systems like I've created graphics rendering, separate rendering engines from graphic objects, database access, abstract different database types, and then file systems, unifying the interfaces for local and cloud storage. Okay, so that is all. And now I'm going to go over a quick demo. Right. So I'm going to go ahead and run the code. All right, so we're going to first go ahead and create a new payment method. We're going to choose from our available payment methods. So we're going to go ahead and choose Google Pay. Okay, and then we have these available gateways. So we're going to go ahead with PayPal, number 2. Okay, so now we have created a Google Play payment method using PayPal. Okay, here's our ID. We're going to go ahead and copy that. Okay, so now we're going to go ahead and try to process a payment. So here's our configured payment methods. Okay, so we're gonna have to enter the ID, which is this over here, make sure there's no spaces. Right, and then you enter them out. So let's say $50. Okay, so here is our process payment. So now let's say I'd like to process a refund. Okay, so we're gonna have to go ahead with the ID. Just gonna copy that real quick. Sure, there's no spaces. All right, so then we could add in the refund, so $15. Okay, and of course we can view the list of configured payment methods. So here it is. Okay, all right, and then we could also view the transaction history. So here is the transaction history. And of course, exit the program. All right. So that was the implementation of the bridge pattern.